Alright, boys and girls, welcome back. Um, Today we're focusing more on graphing, and then we're going to get into a little word problem action. Alright, which will help us understand these graphs a little better. Now, we're going to start with the review of what we've been doing the previous few days. So looking at this, my vertical asymptotes, alright, in this case are what forces my denominator to be 0. So again, x is -3. And my horizontal asymptote is my y value. So y equals 5. Now, our domain and range, all right, remember our domain is all real numbers except for x cannot equal -3. And my range is all real numbers except for y cannot be 5. Alright, so when we draw our graph, our vertical asymptote is at x is -3. My horizontal asymptote is at y equals 5. Alright, and then go ahead and take your calculator. In our y equals menu, we have -2 divided by parentheses x plus 3 plus 5. And graph. Alright, and that looks about right where my asymptotes are. Go to your table and pull out your values. In this case, there's not a lot of nice values. So let's go up and see what we can find. Oh, here's some action. Alright, so I have -1, 4, -2, 3, and -1, 4.5 isn't a bad one. So I got -2.51, -2, 3, and -1, 4. So there's my graph. Now for my y values, excuse me, sorry, for the other graph, let's go in search of these. Let's keep going up. -4, 7, -5, 6, and -7, 5.5. Alright, so -4, 7, -5, 6, and -3.5, 9. And there's your graph there. Alright, now here, these are our other hyperbolas. Okay, so my vertical asymptote is what forces my denominator to be 0. So subtract 5, divide by -4. So x equals +5/4, because a negative and a negative give me a positive. Now, my horizontal asymptote, remember, are your x coefficients. So -3 over -4 is going to give me a +3/4. So my domain is x is all real numbers, except for x cannot be 5/4. And my range is y is all real numbers, except for it cannot be 3/4. So your asymptote is at 5/4, which is just a little higher than 1. I'm sorry, your vertical asymptote is just a little higher than 1. And your horizontal asymptote is y equals 3/4, which is just under 1. Alright. Okay, go ahead and type that in your calculator. Okay, make sure to put the top and bottom in parentheses, find your points. And not only number 2, I want you to do number 3 and number 4. Alright, we've been doing these for a few days now. Please be prepared, because when I check tomorrow, I'm going to be looking that you completed these. Now, go to the last page, and these are the ones we're going to work together. And these are all of our favorite things, word problems. Now, you and your friends are sponsoring a dinner. The cost of catering the dinner is $9.95 per person, plus an $18 delivery charge. Now, you did some of this in Algebra 1. Alright, so if you think about what you learned back in Algebra 1, you had, if we were to write this equation, we would have y equals, or f of x equals now, $9.95 per person plus a flat rate delivery charge of 18. All right, and that's a linear equation. That's what we did a lot of in Algebra 1. All right, but now let's take a look at A here. It says write a model that gives the average cost per person. All right, so now that we've graduated to Algebra 2, our new equations are going to look like this. Well, how do you find the average of something? You take the sum and you divide it by the total amount of people, right? Well, in this case, x is representing our amount of people. So we have f of x equals 9.95x plus 18 all over x. So we've now taken a linear equation and made it a rational equation to find what we want. All right, now this is where it gets a little interesting because I want us to focus on the meaning of the asymptotes. Now they start to tell the story and it makes sense. All right, so sketch the graph of the model and use it to estimate the number of people needed to lower the cost to $11. Well, first let's just sketch a model and take a look at it. So my y equals menu, I'm going to clear it out. I got 9.95, oh, where's my decimal? 0.95x plus 18, close parentheses, all divided by x. All right, and graph that. All right, there's one, and where's the other one? Now, before you get ahead of yourself, I always like to find my asymptotes, all right, to have a sense of where I need to change my window to see my graph. All right, well, we know my vertical asymptote is what makes the denominator 0. All right, where in this case, x is by itself, so x equals 0 is my vertical asymptote. Now my horizontal asymptote is, remember, we take our x coefficient, so it's 9.95 over 1, which is y equals 9.95. So that's my horizontal asymptote. So when we draw my graph, all right, we know horizontal is 9.95, so it's up here. And then my vertical is at 0. All right, and I'm actually going to move this over here to give me some room, because I can see the future, and I know where our graph's going to be. All right, so now that we know my asymptote, is up here at 9.95. So my other graph's probably up here to the right. So in my window, I'm just going to change my y max, and let's just go up to, I don't know, 20. And let's see if our graph is there. And there it is. All right, and the directions just say sketch a graph. So let's just draw a quick sketch of what we saw there. So we're approaching these asymptotes, and we're approaching these asymptotes. Now, the first question says, estimate the number of people needed to lower the cost to $11. So we want the total cost to be $11. So that means we want f of x to be 11. So 11 equals 9.95x plus 18 all over x. So let's multiply both sides by x, get rid of the denominator. 11x equals 9.95x plus 18. Subtract 9.95 to get 1.05x equals 18. Divide by 1.05, and x gives you 17.14. Now, can we have 17.14 people? No. Now, the problem asks you to lower the cost to $11. So if we round to 17, you're actually still be paying $11. So we're going to round all the way up to 18 people to provide that answer. Okay, now, this is the important question. Describe what happens to the average cost per person as the number increases. Okay, now, this is where this asymptote really comes into play. And think about this. All right, we pay $9.95 per person and $18. So the more people I get, let's say I have one person. Okay, you're paying the $9 and an $18 convenience charge, or delivery charge, sorry. Once I have two people, now that $18 goes down a little. All right, so every time you get more people, that $18 gets chopped up into little pennies, all right, or fractions of pennies. All right, and now the reason we never hit 9.95, well, it's because we're never going to pay less than that. All right, no matter how, remember, each point represents one person, what they're paying. So as we get more people, that approaches closer and closer. So the total cost is going to get cheaper the more people you have because this 18 is getting chopped up. All right, so the cost is actually going to decrease. So the more people we have, all right, our cost decrease. Why I put an S there, I don't know. Okay, the cost is going to decrease because that $18 is getting chopped up again. All right, good. Let's try another one. This is another application. Okay, the formula for the sum of the interior angles of a regular polygon is SI, sum of interiors, equals 180 times the number of sides minus 2, where n is the number of sides in the polygon. Now, don't get so hung up on the geometry aspect. Let's just focus on the math. Now, it says write a model that gives the measure of each interior angle. So this is the sum of them all, and we just want to find one. So we're going to say each interior angle is this formula here, and we're going to divide it by the number of sides it is, because this is going to give me the total amount of angles, measures, all right, what they all add up to, and then we're going to chop it into our main piece. So let's say we had an octagon. We had 8. We're going to find out what all the angles add up to, and then cut it into 8 equal pieces. So that's what that's doing. It says sketch the graph. Well, I know my vertical asymptote is going to be 0, and my horizontal asymptote is going to be 180 over 1. Right, so y equals 180. So to sketch my graph, I kind of already know what it's going to look like. X at 0, my y-intercept at 180. All right, so when we put in our calculator, I'm going to go parentheses 180 times x minus 2, double close my parentheses, all divided by x. Graph, I can't really see much, so I'm going to go zoom fit so that it fits the entire graph in there. Oh, it's down at number 10. So zoom fit, and it adjusts your window so that you can see the graph. All right, and we see that it's in these two quadrants here. So let's draw my sketch and move on. Okay, it says sketch a graph, the model, and use it to estimate the interior angle of a regular 40gon. So it's telling you the number of sides is 40. So I have EI is going to equal 180 times 40 minus 2 all over 2. So when you do that, you get 6840 over 40. So your EI is 171. All right. Now so all I did was evaluate that. The final question says, describe what happens to the measure of an interior angle of a regular polygon as the number of sides increases. Now, it's going to get larger. All right, it gets larger, or it increases. Now, think about this. If you have a triangle, all right, let's say they're all the same, they're all going to be 60. We know they add up to 180. If you have a square now, they all add up to 360. So that number increases, right? And as you chop that up, these numbers are going to get bigger and bigger and bigger. Now, it's at 180 because, think about it, a straight line measures 180 degrees. So for an angle to ever go past 180 isn't going to make much sense, because then it would be a flat line, right? And it wouldn't be a polygon. So that's where that asymptote comes from. If you think about it, it makes sense if you tie in everything you remember about geometry. All right, so that's the word problems. We're going to practice a lot of these in class tomorrow, so don't worry. And you'll have plenty of time to ask your questions, and we can talk about this concept a little more. All right, signing off. See you tomorrow.